Good morning, it's October 8th, and this is your Daily Brief in Science. Here's everything you need to know. 3 physicists, John Clark, Michel Devoret, and John Martinez, have received the 2025 Nobel Prize in Physics for their work demonstrating quantum phenomena like tunneling and superposition on a macroscopic scale. Their research confirms that quantum effects are observable beyond microscopic particles, which is fundamental to the development of advanced quantum computing. This work not only pushes forward quantum computing capabilities, but also improves sensor technology used for detecting faint phenomena such as magnetic fields. Additionally, their discoveries support the creation of more secure cryptographic methods. The recognition highlights that quantum mechanics, a field over a century old, continues to reveal new insights and remains central to modern technological progress. Quantum computing is moving from theoretical research into practical applications, impacting cybersecurity, drug discovery, and financial modeling. Current research efforts focus on increasing qubit stability and developing more efficient quantum algorithms, while future prospects include breakthroughs in semiconductors and quantum biology. Companies like Alice and Bob are leading efforts to develop fault-tolerant quantum hardware, attracting significant funding. The Nobel accolade is expected to accelerate investments in quantum tech, benefiting companies such as Google, IBM, and IonQ, and challenging traditional semiconductor industries. This achievement underscores the strategic importance of quantum research, with the U.S. investing over $1.2 billion annually, marking a broader, second quantum revolution. However, funding cuts and political challenges threaten to slow progress, emphasizing the need for sustained federal support. Researchers are working on macroscopic quantum circuits that function like artificial atoms, which are essential for quantum information science. While international recognition grows, disparities remain, with some regions like Portugal still on the periphery of quantum innovation. Experiments demonstrating quantum coherence in large, complex systems challenge traditional views and provide new insights into quantum effects at macroscopic scales. Researchers have developed a new approach to treating Alzheimer's disease by targeting the blood-brain barrier, or BBB, which plays a key role in the disease's progression. This method uses specially designed nanoparticles that activate the brain's natural waste removal systems, specifically increasing the clearance of amyloid proteins linked to Alzheimer's. The technique reprograms the brain's export pathways, making the removal of amyloid beta more efficient without relying solely on drug delivery across the BBB. In mouse studies, this treatment reduced amyloid levels by nearly 45% and led to notable improvements in spatial learning and memory, with effects lasting up to 6 months. Behavioral tests showed that treated mice performed similarly to healthy controls, suggesting potential reversal of cognitive symptoms. Imaging and biochemical analyses confirmed that the treatment reactivated transcytosis pathways, increased levels of proteins like PACSIN2, and improved vascular integrity, supporting its role in vascular repair and amyloid clearance. The lead researcher, Professor Giuseppe Battaglia, stated that if larger preclinical trials confirm these results, clinical trials in humans could start within a few years. He also noted that restoring BBB function might benefit other neurological diseases. Further studies are planned to expand preclinical testing before moving into human trials, which could begin soon if safety and efficacy are established. Experts caution that these findings are preliminary, as they were conducted in mice, and it remains uncertain whether the approach will be effective in humans. Currently, there are no approved drugs capable of reversing Alzheimer's, which affects over 944,000 people in Britain, underscoring the urgent need for innovative treatments. The treatment involves angiopep, 2 conjugated polymersomes, engineered to promote receptor recycling via PACSIN2-mediated transcytosis, restoring BBB function and enhancing amyloid beta clearance. In genetically modified mice, the treatment caused a 50 to 60% reduction in amyloid beta within 1 hour, demonstrating rapid and significant effects without toxicity. Researchers from UCSF and the Allen Institute have developed an advanced AI model called celltransformer, which has produced a highly detailed map of the mouse brain. This map identifies over 1,300 distinct regions, many of which were previously uncharted. The high-resolution map links specific cellular regions to functions, behaviors, and diseases, potentially aiding targeted therapies. The methodology behind Cell Transformer is tissue-agnostic, meaning it can analyze other organ systems or cancer tissues, offering insights into health and disease at the cellular level. One key advantage is its ability to handle large spatial transcriptomics datasets efficiently, addressing scalability challenges in neuroscience. The model's accuracy has been validated by its close alignment with the Allen Institute's Common Coordinate Framework and other existing brain maps, successfully replicating known regions like the hippocampus. It also uncovered finer subregions in complex areas such as the midbrain reticular nucleus. The study, published in Nature Communications, mapped over 9 million cells in the mouse brain, providing a high-resolution, detailed cellular map. This approach moves from broad brain region maps to detailed cellular neighborhoods, improving resolution and understanding. The AI predicts molecular features of cells by analyzing their local environment, enabling hierarchical mapping from cellular patterns to tissue domains. Future plans include integrating gene expression, connectivity, and activity data to develop comprehensive multimodal brain maps. Although currently focused on the mouse brain, researchers believe similar techniques could extend to the human brain within the next decade. Ongoing validation efforts aim to better understand the functional roles of newly identified subregions. This work exemplifies a significant interdisciplinary integration of AI, biology, and neuroscience, marking a paradigm shift in brain research. The Trump administration has proposed a 47% reduction in NASA's science budget, threatening to halt ongoing missions and future projects to the Moon and Mars. This proposal has faced widespread opposition from Congress, scientists, and space advocates who warn it could be an extinction-level event for space science. Congress is currently working on appropriations bills to reject these cuts and maintain NASA's funding and staffing levels. Organizations like the Planetary Society and multiple members of Congress are leading the opposition, emphasizing the importance of continued investment in space exploration. UC Santa Cruz researchers play a significant role in NASA projects, including fixing the Hubble Space Telescope's optics and modeling solar activity that impacts Earth. Professor Natalie Batalha from UC Santa Cruz has identified over 2,700 exoplanets, including the first rocky planet outside our solar system, advancing planetary habitability research. NASA's Science Mission Directorate manages critical missions such as the James Webb Space Telescope, Perseverance rover, and Landsat 9, which are essential for understanding Earth, the solar system, and the universe. The scientific community stresses that sustained NASA funding is vital for technological innovation, inspiring future scientists, and societal benefits like GPS and climate monitoring. Over 300 scientists and advocates protested on Capitol Hill, urging Congress to protect NASA's budget amid threats from a government shutdown and potential layoffs that could jeopardize future missions. The White House's budget proposal also includes defunding over 40 projects, including Mars sample return and climate-focused missions, citing fiscal responsibility. Despite bipartisan opposition, advocates emphasize that passing legislation to safeguard NASA's budget is crucial for maintaining U.S. leadership in space. Media outlets like CNN highlight the potential impacts of these cuts on NASA's scientific and exploration efforts. These proposed reductions contrast sharply with China's accelerated space program, including plans for a Mars sample return by 2028 and other planetary missions, underscoring geopolitical competition. A recent clinical trial offers promising news for men with advanced prostate cancer carrying specific genetic mutations. Researchers from University College London conducted a Phase 3 study involving 696 men across 32 countries, all with alterations in DNA repair genes like BRCA1 and BRCA2. The trial tested a combination of the drug niraparib with standard treatment, finding a 37% reduction in the risk of cancer progression overall. Among patients with BRCA1 or BRCA2 mutations, the risk reduction was 48%. While overall survival data are still immature, The results suggest the combination could delay recurrence and possibly extend life. The study also indicated a trend toward better survival with niraparib, but longer follow-up is needed to confirm this. Experts are calling for increased genetic testing at diagnosis to identify candidates for targeted therapies like niraparib. Professor Gerhard Adard emphasized the importance of genomic testing to determine eligibility, noting that niraparib has already received approval for certain patients. The treatment was associated with side effects, including anemia, high blood pressure, and a higher incidence of treatment-related mortality, with 25% of patients requiring blood transfusions. Despite these risks, the potential to delay disease progression underscores the need to weigh benefits against harms. Further research is necessary to confirm long-term survival advantages and assess how advanced imaging and broader genetic testing could improve outcomes. Given the high global prevalence of prostate cancer, with approximately 1.5 million new cases annually, developing targeted therapies remains a critical goal. The story also highlights increased advocacy for early screening, inspired by cases like Sir Chris Hoy and King Charles, who was diagnosed during treatment for an enlarged prostate. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.